telling you from the starting, this is the question based on nodal analysis. In this we are having dependent source, and in this we are having the concept of nodal, like super node also. Okay, so according to this we are having two nodes. One node is VA and another node is VB. If we'll apply KCL, first step is apply KCL at node VA, right? So if we'll see, two currents are the, one current is the incoming current and three current are the outgoing current. I1 is the incoming current, I2, I3 and I4 is the outgoing current, right? So we can write down I1 is equal to I2 plus I3 plus I4, right? As you can see that I1 is moving from 0 to VA, right? 0 to VA, and in between we are having battery, so we'll have to take second sign of the battery, right? So that would be 0 minus VA, and for the battery we have to take the second sign. Second sign is positive, right? So we can write down 0 minus VA, and we have to take the second sign of the battery, that is positive, divided by the resistance. How much is the resistance? 5 ohm, correct? Now next is I2. I2 is, as you can see that I2 is moving from VA to 0, so we can write down VA minus 0 divided by 3, right? So I2 is VA minus 0 divided by 3 plus I3. I3 is the dependent source, like this is the dependent source. And which dependent source it is? It is depending on voltage, so it is a voltage dependent, and arrow is there, so it is a current source. So it is a voltage dependent current source. Okay, so for current source I told you I'll write down I3 value is how much given, that is 8 Vx. So this is also current source and I3 is also the current, and both the currents are moving in the same direction. Okay, both the currents are moving in the same direction, so we can write down I3 is equal to 8 Vx, correct? So I3 is equal to 8 Vx plus I4. I4 is moving from VA to VB, right? I4 is moving from VA to VB, so we can write down VA minus VB divided by 9, because I4 is moving from A to B, correct? So we can write down I4 is VA minus VB over 9. We got our first equation. In this two variables are there. One variable is VA, another variable is Vx, and another variable is VB, right? So for three variable we need three equations. Now we'll apply KCL at node B, right? So node B, you can see that two currents are incoming current and one current is outgoing current, correct? So we can write down I3 plus I4 is equal to I5 plus I6, right? I3, we know that I3 is how much, that is again 8 Vx, right? I4 also we know, that is VA minus VB divided by 9. I5 is moving from VB to 0, so that would be VB minus 0 divided by 3. And I6, in this we are having super node, right? Because there is no resistance over here. If there is no resistance, there is a concept of super node, right? So I told you, if there is a concept of super node, we'll write down as it is I6 only. Okay, now as you can see, for one equation we need to make for from the super node. Just in I6, your I6 is moving from VB to 0, so we'll write down VB minus 0, and in between battery is there, we have to take the second sign of the battery, that is minus 7 is equal to 0, correct? This is the equation we got it from the super node. From this we can conclude that VB is equal to 7 volts, right? Now one dependent source is also there. Dependent source, as you can see, it is depending on voltage, right? So voltage is present here, right? As I told you, it is depending on mother or father, it is depending on father. So I told you for father we always have to make use Ohm's law, right? As you know, Ohm's law is V is equal to I multiplied by R. V is here Vx, right? You can see that V is here Vx, so we can write on Vx. Current here is how much? I5. Current is I5, and resistance is how much? 3 ohm, right? Resistance is 3 ohm. So this is our fourth equation. Okay, so how many equation we need to make? One for this node, one for this node, two, one from the super node, 3, and one for the dependent source, fourth. So we have to make four equation, four variable. Then we can easily put it in the values, like we can put VB value here. Vx is 5 I3. Okay, sorry, 3 into I5. Then we can solve it after putting all the values.